Hello, my name is Sasha Azad, and I'm here to talk to you about our paper, Little Computer People, a survey and taxonomy of simulated models of social interaction. It is our position that since modeling of virtual characters has become a large part of the scientific practice in our field, we must develop a common taxonomy to discuss these models and enable us to identify, classify, and accumulate existing knowledge. Towards this goal, we conduct an in-depth analysis of a selection of existing social simulation artifacts and conceptualize such a taxonomy. Humans are social. Their social systems both complex and contextual. Creating believable simulations of large populations of characters in virtual worlds represents a grand challenge for narrative intelligence. Social characters have been used widely as a game mechanic, with characters forming emergent narratives and responding affectively to player interactions and increasing player immersion. However, despite the plethora of social character models developed, there is no consensus on what constitutes a social simulation. Across social simulation artifacts, we come across terms such as social state, relationships, influence, and so on. However, missing a formal definition, these terms can mean any number of things. For instance, the term social state could refer to any combination or subset of emotions, relationships, personality, or intentions. A further discussion on existing research terminology can be found in our paper. Furthermore, this lack of consensus impairs reuse, including the ability for outside groups or new members of the field to contribute by building on prior work. Secondly, it impairs reproducibility, with system descriptions and results of experiments reported in ways that rely too much on metaphor and intuitive explanation rather than formal definition. These two problems together impair comparability, making it difficult, if not impossible, to meaningfully compare the effects of two systems or features. Finally, we hope this will ease the way to better research collaboration in the future. Towards this goal, we conducted an investigation of existing social simulation projects, some research-based and commercial game franchises. We organized this information into a dataset, conducted thematic analysis, and created a vocabulary and taxonomy of modeled social characters. In our developed taxonomy, we were able to classify interactions as belonging to or affecting some combination of the following main themes: communication, flow of knowledge, relationships, and emotions. While we cannot go into detail on these themes during this talk, we will provide a short overview of each theme, allowing readers to explore them at depth in our paper. First, we see two interactions of dinner conversations from our dataset. On the left, in The Sims, we see characters communicate verbally and using gestures. On the right, in Versu, characters communicate primarily in a verbal manner, using text. Similar interactions in our dataset led us to classify communication under the primary themes of verbal, physical, or emotional communication. Secondary themes were derived from these and include gestures, queries, and a final category termed as mixed communication. Next, knowledge in our taxonomy was classified into creation of knowledge, where you learn new information through, say, eavesdropping on a conversation, propagation of knowledge, say, sharing information about a hobby, or termination of knowledge, seen as characters forgetting information over time. With relationships, romantic relationships were commonly simulated in our surveyed artifacts. Here you see two such relationships and their interactions, a newly married couple kissing and a date proceeding on its way. Aside from romantic relationships, we were able to identify and classify further relationship types commonly simulated in our surveyed projects. Apart from types, relationships were seen to have attributes, which are an encoding of social norms or customs associated with the relationship, dynamics, which are primary and secondary derivatives of the growth and decay of relationships over time, and relationship dimensions such as trust or social rank, representing the individual character's perception of their relationship. Finally, we categorize emotions as represented in our dataset. During our analysis, we realized the factors and principles we identified in our dataset are those commonly associated with the field of emotional dynamics. We structured these discovered factors using the principle of contingency, which states emotions consist of responses and are contingent on external or internal events. Principles of inertia versus regulation, describing how emotional states display a general inertia, having the tendency to carry on from one moment to the next. And the principle of interaction, describing how emotions continually interact with, augment, or blunt one another. For a more detailed descriptions of these themes, we ask the reader to peruse our paper. To conclude, We identified key differences among social systems that are existing. We were able to propose a taxonomy for components of social simulation systems to inform development for future development at work and storytellers. We were able to identify what was missing or unseen. While the set of phenomena our surveyed artifacts chose to simulate is interesting in their overlap, we found equally interesting a set of social phenomena or theories they did not simulate and what we did not come across. Our unseen or unspun tales make for unexplored territory in the space of social simulation design that can lead to exciting future crossovers between social science, game design, and artificial intelligence. Finally, we posit our taxonomy can better facilitate the understanding and use of agent-based modeling, allowing for better communication and collaboration amongst researchers and practitioners developing social simulation system. Our paper describes in greater detail how this taxonomy can be operationalized in the future and used to fulfill our goals to reuse, reproduce, and compare existing models. Thank you.